All right, we're looking at an example here of an open air column that is going to be open on both ends. And what this example is saying is we're going to find out the length of that air column. So you want an open air column to play a note of 1024 hertz as the first overtone. First overtone, so that means the n equals 2 standing wave, right? Remember, there's the fundamental frequency, then the first overtone. On a sunny 30 degrees Celsius day, determine the length of the air column you should make. As soon as I see this temperature, I'm thinking I need to find the speed of sound, so I'm going to do that really quickly. 332 plus 0.6 times 30 degrees Celsius. So I've got a speed of sound of 350 meters per second. All right, with that in hand, I have a frequency, I have a speed. I want to know the length of the air column I should make. It's open on both ends, so it's following this pattern. There's really L equals N lambda over 2, but I'm dealing with the N equals 2 case. So what that means is that my length is going to be equal to my wavelength. So with that in hand, I know what I really need is my wavelength if I want to figure out the length that I should make this air column. Speed of sound is 350. The note I want is 1024. So I can use my universal wave equation to figure out what wavelength would be associated with that frequency. So I get a wavelength of 0.342 meters. Because I had an open air column, I have this simple relationship with n equals 2, where I got 2 lambda over 2, so my L is just equal to my wavelength. And so if I want that, I should make my open air column 34 centimeters. Try that again. 34.342 meters, or 34.2 centimeters. So that's how you would decide how big to make the air column to match the frequency that you want to produce.